Hello friends, welcome to the another tutorial of basic electronics module. In this particular tutorial, we are going to learn about switches. That what are the working of switches, basic types of switches, their working and their applications. Today's chapter is divided into four different types. In the first type, you will be introduced to the basics of switches. In the second part, you will see the contact terminology of switches. In the third type, you will see the different types of switches, and in the fourth part, you will see the applications of switches. So let's start with the first introduction section. So in this section, you will learn the basics of switches. So first of all, what are switches and where you can see them? So let's just briefly introduce you with switches. So switches are something that are used to connect and disconnect some of the electrical circuits for which they are connected. So the this kind of switches you can see in your house, in your office, in industries, in schools, and in commercial areas too. For example, you want to turn on your light, your television, your washing machine. So there are always a switch particularly connected to it which turns it off when you require them, and to turn that particular device or equipment you just turn them off by switching off. So these are the switches. So switches does what? They just normally open and normally closed. They are in this two operating modes that it performs the function is in normally open and normally closed. In normally open, the path through which a current flows is open. Hence, the device connected to it is in off state. And in normally closed state means the path through which your current is flowing has closed loop. Hence, your current will flow through the device connected to it and it will turn on the particular device. So, in electrical engineering, a switch is an electrical component that can disconnect or connect the conducting path in an electric circuit, interrupting the electric current or diverting it from one conductor to another. Means what it normally does is in normally open state it's just interrupt the flow of current, hence turning off the device and providing a conducting path. In normally closed state it turns on the device or equipment. The most common type of switch is an electromechanical device consisting of one or more sets of movable electric contact connected to external circuit. External circuit is your load circuit to which your load is connected, or you can say the device you want to turn on and turn off. So these electromechanical switches are widely used and widely preferred switches, and they are consist of one or more sets of movable electric contact. Means they have some internal contact operation in this type, or in this contact concept. They use normally spring to contact both the switch with external circuit, and hence providing a conducting path or interrupting the same path. When a pair of contacts is touching, current can pass between them. Means when switch and the external circuit, the the combination of these two and providing where whatever a conducting path they are in touching mode, or they touch each other, then it will provide a current, a non-interrupted path to flow through them. While when the contacts are separated, means whenever the contacts to the external circuits are interrupted or separated, means they are not touching, then the current can not be flow through the same area or same path, and hence the connected device stays in the off mode. So let's see what is a switch. A switch is an electrical component that is used to turn on and turn off any equipment like a television, washing machine, lights, fans, etc. When the switch is off, the circuit is open. Means whenever your switch is off. Switch in off state indicates that the particular device connected to that switch is in off state. Hence, you can say the circuit is in open type. Uh, if you remember, we have seen the circuit, different types of circuit. Means basically there are two types of circuits. First is open circuit and the another one is closed circuit. In open circuit, the switch connected to it and the external circuit, the linkage path of both of them is open. Hence, there would be no flow of current. The current will flow when the circuit is closed. So, by means of connecting both the circuits with each other, that conducting path will be completed, and hence the current will start flowing through the device. Maybe it is a television or washing machine or your simple LED, whichever device is connected onto the load side. The current will start flowing from that particular device, turning the device on. An ideal switch would have no voltage drop when closed. So, if you are talking about ideal switch, then an ideal switch is characterized when it has no voltage drop. Means across this switch there should be no voltage drop, or voltage drop, a voltage drop should be of minimum near to zero, and would have no limits on voltage or current rating. Means it would be independent of voltage and current rating. It would have zero rise time and fall time during the state changes. Means whenever it changes its state from normally open to normally closed, it will have zero rise time and fall time. So it should not take much time from changing its state from normally open to normally close. Means as soon as you press the switch, it should turn the particular device in on state, and as soon as you close your switch or switch off, it should instantly turn off that particular device and would change state without bouncing between on and off position. So these are the characteristics of an ideal switch. So an ideal switch should have first no voltage drop when closed and would have no limits on voltage or current. Second, it should have no it would have zero or near to no rise time, zero rise time and fall time during state changes, and would change state without bouncing between on and off position. These are the characteristics. Now let's see the making of switches, that how switches can be made. So switches are made in many different configurations. They may have multiple sets of contacts controlled by the same knob or actuator, and the contacts may operate simultaneously. Means the switches should have may have different contacts, number of contacts controlled by the same knob or actuators, sequentially or alternatively. A switch may be operated manually, for example, a light switch or keyboard button, or may function as a sensing element to sense the position of a machine part, such as liquid level, pressure, or temperature, such as in thermostat. Many specialized forms exist, such as toggle switch, rotary switch, mercury switch, push button switch, relay, and circuit breaker. So these are the different types of switches which are used for just turning on or turning off a device or interrupting a conducting path. So this is how, depending on the purpose, the switches are made in variety of different configurations. Now, let's see the two different contact terminology on which the working of switch is dependent. As you can see in this image, there are two types of contact terminology which are open and closed. So, the main two terms for switches are normally open, which is also known as NO, and the second is normally closed, which is also known as NC. Means the two state of switches are, first is NO state, which is equals to normally open, and the another one is NC state, which is also known as normally closed state. So let's just see one by one both of them. First, let's see normally open, that what happens when switch is in normally open or NO state. So in NO state, or as in the name itself suggests, that it stays in normally open mode. Means the circuit, external circuit or load circuit, is the does have open path. Means in this type of mode there is a breakage of path, there is no closed loop. When the contacts are separated by an insulating air gap, they are said to be open, something like this. So this is for example, this is just switch contact, and at this particular time this mode is normally open, means there is an interruption of conducting path, or there is an interruption of current flowing through the LED or your bulb. This is your bulb, this is your power source, and this is your switch. Now in this particular type, your switch is there to interrupt the current flowing through this bulb, hence turning it in off state. Whenever you require or you want to turn off this particular device, you just switch it off, means you just provide a interruption. So here the switch is responsible for interruption of current, and hence there would be no current flow between the bulb's terminal. Also, this type of term is known as break for opening of contacts of the particular load circuit, because it is breaking the path. The term break is also used for this kind of operation. So in normally open state, the conducting path is interrupted, hence the current through the device or load connected to the switches is in open path, and hence it is in off state. The second terminology is normally closed. Means what happens when a circuit has closed loop. Means how you can refer this as a normally closed term. This is how a normally closed switch looks like. Normally closed means there is a closed path to current to flow through particular this to this and to this. As soon as the current reaches here, there will be a flow of current through this bulb, and hence the bulb connected to the switch would be turned on. In electronics, switches are classified according to the arrangement of their contacts. A pair of contact means this contact and this contact. These contacts are for specifically this normally closed operation. They are not separated. They are in the joining condition. So, a pair of contact is said to be closed when current can flow from one to other, means from this contact to this contact. Through this, the current can flow from here to here. Hence, this is called as closed. The term make is used for closure of contacts. So whenever both the contacts are in closure, they are also known as make. So this is the making of circuit, and this is breaking of circuit, means you are breaking the circuit, means there is a breakage, hence this is the breaking of circuit. And in this particular type you are making the circuit to current to flow through this, hence this is the making of circuit. The contacts can either be normally open, NO, until closed by operation of the switch, or normally closed and opened by the switch action. So after some time you can just separate this both contacts, and your switch would be in normally open state and the bulb turned off. After some time you can close these contacts by switching it or by making the circuit, and you will see that your bulb connected to it will be turned on. So these are the representation. First is for closed circuit. When the circuit is in closed mode, there will be a flow of current without any interruption, illuminating the bulb connected to it. Now there is a breakage or interruption of current in the circuit, hence it is known as open. There is an open part in the circuit, hence it is known as open circuit, turning the bulb off. So whenever there is a switch whose contacts are not joined or together, it is known as open circuit, and also the bulb or device connected to it in off state. And when both the contacts are joined together, or not separated, the current will flow through the device and turning it on. So this is how normally open and normally closed state is denoted or is referred for switching purpose. A switch with both types of contact is called a changeover switch or double throw switch. Means a particular single switch is able to break the circuit and make the circuit. So this kind of operation is changeover, means it can change from one to another. So this kind of switches are known as a changeover switch or double throw, means it provides two paths, alternatingly two paths. So they are also known as double throw switch. This may be make before break, or which momentarily contacts both circuits, or maybe break before make, which interrupts one circuit before closing the other, means it interrupts one circuit before closing the other. So these are the double throw switches. So let's see the working of the switches, that how this kind of switches work. A switch may be directly manipulated by a human as a control signal to a system such as a computer keyboard button, or to control power flow in a circuit such as a light switch. So a switch are used, or switches are there to manipulate by a human control. So we turn on and turn off switches to turn on or off our home appliances. So these are manipulation by a human to control a signal, whether it is a computer keyboard or to control a power flow in the circuit. Automatically operated switches can be used to control the motions of machines. For example, to indicate that a garage door has reached its full open position, or that a machine tool is in position to accept another work piece. So this kind of activities requires a switch operation, but they are used or controlled by some other motion of the different machines. Switches may be operated by process variables such as pressure, temperature, flow, current, voltage and force, acting as a sensors in process and used to automatically control a system. So these are the different quantities through which you can control the operation of your switch, means from normally open to normally close or normally close to normally open. So you can use a particular sensor which senses either pressure or temperature or flow of current or voltage. So you can use it as a sensor in a process and you can automate the control system. So now this is the third part of our today's lecture, which is the different types of switches. In this we will see the different types of switches. So generally the switches can be divided into two types, which are electrical switches and the other is mechanical switches. So basically in electrical switches, which happens is from electrical signal, means giving the switch to an electric signal, they can be operated, means they turn the circuit on or off. So this work under the influence of semiconductors. While in mechanical switches, what happens, so it happens by physical human operation. So after operating it manually, they will turn on or turn off the circuit connected to it. So this require manual contact with the switch for operation and are classified into various different types depending upon the poles. Poles means number of input circuit available to the switch, and throws means number of paths for the flow of current available to the switch. So these are the main two types of switches, electrical and mechanical. So we will see first mechanical switches. So in mechanical switches, these are the six different further categories. First is single pole, single throw. Means it will have a one input circuit and it will have one single path for current to flow through. So single pole, single throw. Then after there is single pole and double throw. Single pole means it will have one input circuit and two different paths for current to flow through. Then after there is double pole single throw, means two input circuits and only one path for current to flow. Then double pole double throw means it will have, or it has two input circuits and two current paths for currents to flow as well. Then after there is two poles and six throws, means two input circuits and six different paths to current, six different paths for currents to flow through. Then after there is another category which is momentary operation switches or momentary control switches. In this, the push buttons, press switch, pressure switch, temperature switch, toggle switch and rotary switch are included. So this is how your SPST, SPDT, DPST, DPDT and DIP switch looks like. So from this you can see it is SPST, means single pole. Here will be available only one circuit and the current has only one path to flow through. But in SPDT means it will have only one input circuit. The circuit will be one, but the current have two different paths to flow through. Means from entering from here, it will have two paths, either this way or this way. So it will have two different paths to flow. In DPST means two input circuits and single paths, means this input circuit has this particular path to flow through, means only one path for current to flow, and this input circuit will have this path to flow through. Now DPDT means two input circuits. This is two input circuits, one and two input circuits and two different paths for current to flow. So from entering from here, it will have either this path to go through or this path to go through. Entering from here, it will have, say, first path to here and second path to flow through from here. And this is DIP switch. So this is how these switches are represented, and this is image representation of each one of them. Now first we will discuss what is toggle switch. So this is how the toggle switch looks like. So toggle switches are actuated by lever angle. This is something you can call a lever angle in one of two or more positions. See, you can see here on, off and off. It has three different operation variations. So by adjusting lever or turning it forward and backward, you can change its type. The common light switch used in household wiring is an example of a toggle switch. So these switches are used in traditional homes many years ago. Now they are replaced by our new switches, but in former, or you can say in ancient time, they were using this kind of toggle switch for light switches. Most toggle switches will come to rest in any of their lever position, while others have an internal spring mechanism returning the lever to a certain position. Means there are some toggles which have in no return position, and there are some toggle switches which has internal spring which enables it to rest or to come back at a particular position, allowing for what is called momentarily operation. Now next category is push button switches. So you can see this kind of push buttons in your video game remote consoles. There are these push button switches are used in some of the video games, also in some of the computer games. There are this kind of push buttons are available. So push button switches are two position devices actuated with a button that is pressed and released. So push button has normally two states. First is when pressed, when you are pressing that push button, that is the first position, and second is when you release your hand off. So that is one which is pressed and the another is released. Most push button switches have an internal spring mechanism returning the button to its out. Means whenever you are playing your video game, until you press the button it will stay in that in mode, but after you turn back, or after you get off your hand from that particular button, it will come into its reset, or you can say out position. So it will be done by a spring mechanism connected to it. For momentarily option, some push button switches will latch alternately on or off with every push off button, and other push button switches will stay in their in or say pressed position until the button is pulled back out. So in this category also there are two different types. Means there are spring mechanism available to for button to come out at some fixed position, and there are also push buttons available which have once pressed will stay in that same position until you press them or pull back out. So these are two different types of push buttons. Then selector switch. So as the name suggests, selector switch means you can select one of the position from many positions. So selector switches are actuated with a rotary knob or lever. As you can see here, uh, uh, at selector switch has three different modes. First is shift, then off, and then sure. So if you want to select any of these three, you just need to turn. If you want to go here, then just turn it over here. If you want to go to select ship area, then you will have to move it into this direction. So it can select one from many different positions. Like a toggle switch, selector switches can either rest in any of their positions or contain spring return mechanism for momentarily operation. So if it has a spring connected to it, means spring return mechanism connected to it, then it will come to some it's you can say initial position. But if it's not have the spring return mechanism, then it will stay in the position wherever you last operated it. So these are the switches which are you can see in volume knobs, or you can say in mixtures, means in washing machines, etc. The selector switches are used in this kind of, or you can say microwave or oven. This kind of switches are used there. And then after, this is a joystick switch. This is a joystick module. So in joysticks, what basically is there is a lever, and this is lever. This is joystick module, and this portion or this particular part is known as lever. So you can press your lever back and forth and left and right. This kind of switches you can see in remote control cars, video games, and some robotics operations. This kind of switches are used. A joystick switch is actuated by a lever free to move in more than one axis of motion. One or more of several switch contact mechanisms are actuated depending on which way the lever is pushed, and sometimes by how far it is pushed. The circle and dot notion on the switch symbol represents the direction of joystick lever motion required to actuate the contact. Joystick hand switches are commonly used for crane and robot control. So these kind of switches are used in cranes, robot controls, and some of them are used in remote control cars also. Some switches are specifically designed to be operated by the motion of a machine rather than by the hand of a human operators. Then after, these are the slide switches. So slide switches are nothing but they are operating on the mechanism of slide or moving them. So slide switches are mechanical switches using a slider that moves from open means in off condition, and position to closed means on position. They have only two operating stage, which are normally open, which is off, and closed, which is on. Then after, actuator, the moving part that applies the operating force to the contact is called the actuator, and maybe a toggle or a dolly or rocker, a push button, or any type of mechanical linkage. So this is the representation of actuator, and this is how your slide switch looks like. So these are the knobs, or you can say these are the moving parts. You can turn it this side or this side. If you turn it here, the circuit or the device connected to it will behave accordingly. So these are the slide switches through which you can slide and turn on and off the device connected to it. Now the second type is electrical switches. So these are the different types of electrical switches, which are bipolar junction transistors, MOSFETs, relay, triarc, power diodes, IGBT, DIAC, get, turn off thyristor, and SCR. These are the different electrical switches. So let's first see relay. What are relay? So this is how your relay looks like. Relay works on the principle of electromechanical, means giving it to an electric signal, it performs a mechanical task. So this switch is also known as electromechanical switch. When the current passes through a coil, it will create a magnetic field around the coil. This amount of magnetic field depends upon the amount of current passes through the coil. Arrangement of the contact is done such a way that if current is increased with a certain limit, contacts are energized and change its position. So whenever there is an internal mechanism, the mechanism works that if the current is increased with certain limits, means some specified already, or you can say preset value, the current is increased with some preset value, then contacts are energized, and this energized contacts changes their position from, you can say, normally open to normally closed, or normally closed to normally open. And that's how the relay performs their tasks of turning on or turning off the connected devices or the latter equipments. Sometimes relay uses bimetallic strip to sense the temperature for safety purpose to for safe as operating safely. Now the another one is bipolar transistors. So what are transistors? So transistors, typical transistor, this is how your transistor looks like. It has three terminals, or you can say three legs. One is emitter, second one is base, and another one is a collector. So the three legs or three terminals are emitter, base, and collector. Transistors work in three regions, which are cutoff, saturation, and active region. But for switching purpose, the active region is not used. Only cutoff and saturation regions are used for transistor when you are using it as a switch. If sufficient amount of current is available at base, if sufficient amount of current is available at base terminal, the transistor enter into saturation region. So specific amount of current is available at base terminal will move the transistor into saturation region, and current will flow through collector emitter path and transistor act as an on switch. So whenever there is a sufficient amount of current, the base terminal will push the transistor into saturation region, and because of that there will be a current flow through collector and emitter, and it will enable the transistor to work as an on switch, means as an on operation. If base current is not sufficient, circuit stays in open condition, and current will not flow through the collector emitter path, and transistor enter into cutoff region, and it will act as off switch. So if the base terminal has sufficient amount of current, it will push the transistor into saturation region and collector, and there will be a current flow through collector emitter path, and transistor will act as on or as on switch. If the current is not sufficient, then there will be no saturation region and no current will flow through collector and emitter path, and the transistor will stay in off condition. So that is how you can use a transistor as a switch. Now MOSFET, the abbreviation MOSFET suggests the metal oxide semiconductor field effect transistor. Now this kind of transistor has three terminals, which are gate, drain, and source. Now this MOSFET is work in two basic forms, which are depletion type and enhancement type. If gate source voltage, means VGS, is not sufficient, the MOSFET works as depletion type, and depletion mode of MOSFET is similar to off switch, means VGS is not enough, means gate source voltages is not sufficient, then this MOSFET will stay in off condition, or you can say it will behave as off switch. But when the gate source voltage, means VGS, is sufficient, then MOSFET works as enhancement type, means this mode is also called as an on switch. So if VGS is sufficient, then the MOSFET will work as on switch, and if VGS is not sufficient, then the MOSFET will work as an off switch. Now the another type is power diodes. So these are nothing but one kind of diodes which will have anode and cathode terminal, but it will use a power signal to turn on or off the connected device. So it has two terminals, anode and cathode. If anode is positive with respect to cathode, diode is in forward bias and acts as an on switch. So the basically what this performs is, whenever the signal provided onto anode and cathode, the anode terminal is more positive than your cathode terminal, then the diode is called in forward bias region, and in forward bias region it will behave as an on switch. But if cathode is positive with respect to anode, then diode will be called in reverse bias situation, and in this particular situation this power diode will work as a off switch. So these power diodes are used where in rectifiers, voltage multiplier circuits, and voltage clamper circuits. So these are the operating or you can say application region of this power diodes. Now, this is the last part of our today's lecture, which is the application where you can use this kind of switches. So basic operation of a switch is to make or break an electric circuit. By making, you can on the particular thing, and by breaking it, you can off or you can turn off the device or circuit. So the applications are, first, the application of SPST switches are: the switch contains one circuit with no NO, means normally open, or NC, means normally closed contacts. We can see this type of switches in applications that only need on and off states. So these are the switches where are used where only on and off states are required. While SPDT, means single pole double throw switches, it contains one circuit with changeover contacts, means it has more than one path, means it has more than one path for current to flow through. These are good to choose when we need to select between any two circuits. Then after DPST switches, means double pole single throw, the switch contains two circuits with normally open or normally closed contacts. This can be used when there is a need to use two circuits at the same time. Means whenever you are required to use two circuits at a single time, then you can use this kind of switches. Then DP-DT switches. The switch contains two circuits with changeover contacts. Means there are two circuits as well as two paths for current to flow through. So this was all about switches and its application and the different types. Thank you so much for today.